Okay, I hope you've had a chance to actually have a look at deriving the Boolean equations for these outputs here. So look, let's go ahead and have a look at this together. Okay, let's have a look at north-south green. Okay, now you'll notice that north-south green is occurring in this particular state. So look, I can take a bit of a shortcut here, and I don't need to worry about the switch, okay, because it is occurring in that state. So I can actually say north-south green is equal to, what is this, A bar, B bar, C bar. So that's an A bar, B bar, C bar, or what else have we got? Let's come on down. Well, it's also occurring in this particular state here, isn't it? So look, there's north-south green. It occurs in this state, okay? And so we can write that down as what? A, B bar, C. So that's A, B bar, C, all right? And that's north-south green, okay? Let's have a look at north-south yellow. So north-south yellow, okay? All right, we'll come on down the column. There's a product term here. That's the only product term. Let's read off what state that is occurring in. That's the A bar, B bar, C state. So that's really A bar, B bar, C state. And that is north-south yellow. Okay. All right, let's have a look at north-south red. Can you see that there? Okay, yes. So let's look at that. North-south red, that is equal to, well, there are a number of product terms here, so let's see what we can write down. There's one here. That's occurring in really that state there, which is A bar, B, C bar. So that's A bar, B, C bar, or what else have we got? It's occurring in that state, isn't it? Okay, which is the A bar, B, C state. So that's the A bar, B, C state. Where else have we got it? Well, we've got it occurring here, haven't we? Yes, so that's what? A, B bar, C bar. So that's or, that's the A, B bar, C bar state. Okay, anywhere else? Yes, here, isn't it? Okay, that's A, B, C bar. So that's an or, A, B, C bar. And finally, we've got it occurring here in the A, B, C state. So that's or, A, B, C. Okay? All right. Now, you would think that we should be able to minimize this. Now, note there are, what, 3 variables here. So let's give it a go and see if we can actually minimize that. All right, so I'm going to draw my 3-variable K-map. Here it is. And we'll plot that function. Okay. So what have we got? We've got A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, and 1. All right, let's plot the terms. That's A bar, B, C bar. So that's A bar, B, C bar. So I've got a 1 sitting here. Next term, A bar, B, C. A bar, B, C. Got a 1 sitting here. Next term is what? That's A, B bar, C bar. A, B bar, C bar, 1 sitting here. Then I've got A, B, C bar. That's the A, B, C bar, 1 sitting here. And then I've got A, B, C sitting over here like so. Well, can I actually minimize that? Well, yes. I can certainly group these together like so. And so I can write off north, south, red being equal to, okay, reading this, what do we have? This would just simply be B, wouldn't it? What else? Well, I can grab this guy with this guy over here, so that's or. Reading this off, that would be A, and what is common over here is really, what do we see as we look from here to here? We see really a C bar, isn't it? So that is C bar, okay? Okay, now let's have a look at the weight output. Now, look, you'll notice that basically it is always 1 except when we're in this particular state over here, which is what? It's the 0, 1, 1 state, okay? Now look, what we could do is we could actually implement the 0 and simply invert. If you implement the 0, you get the bar, as it were, of the function, or you get the inverse function. And so we could say, saves us a bit of time, we could simply say that weight, okay, is really equal to, if we implement that, okay, we're implementing the bar of weight. So let me put a bar over this, and I read this off, and I have what? That's A bar BC. So that's A bar BC. And so therefore weight would be equal to A bar BC with a bar over the whole thing. And of course, by De Morgan, we know that that would simply be equal to A or B bar or C bar. And that is weight. All right. Well, let's have a look at go. Come on down. Here is go. Well, go is only existing in this state, which of course is the A bar BC state. So we could say that go is really equal to what? It's really equal to the A bar BC state. In essence, go is what? It's really the inverse of weight, isn't it? So if you're not waiting, you're going, okay? All right, what about reset? Okay, let's have a think about reset. Okay, reset is just occurring in one state, so that's really easy. And so we can simply say that the reset here is really equal to, reading that off, that's A bar, B bar, C. So that's A bar, B bar, C. And that is the reset. Okay, well, now let's think about this guy here, the last one, which is the clear. All right? Okay, so LCLR, we know it's a low-acting signal, all right, but you still implement the ones. Because you want, when you're in this particular state, you really want, in a 0, 0, 0 state, you want that guy to be a 1. It's only in the 0, 1, 0 state that you want that to be a 0, or in the 1, 0, 0 state you want that to be a 0. Elsewhere, it's a 1. So you are still implementing the ones, okay? So let's just write down the product terms, okay? So LCLR is equal to, well, it occurs in that state, and that's the A bar, B bar, C bar state. So that's A bar, B bar, C bar state, okay? All right, where else? Well, it's in this state here too, isn't it? Well, what is that? A bar, B bar, C state. So that's an OR, A bar, B bar, C state, okay? Or, where else? Okay, is true in that state, which is the A bar BC state. So that's A bar BC state. Or, that's got that. It's true in that state, isn't it? Yes, read that off. That's A B bar C. So that's A B bar C state. Okay. What else? Or, so we've got that state. What about this state here? That's A B C bar. So that's A, B, C bar, or our last case over here, which is A, B, C. So that's A, B, C. All right, now what we should do now is see how that minimizes. Okay, that could easily be plotted, what, on a 3-variable map, and we can see where we go with this. All right, so let's do that. Okay, so let me see if I can fit this in. All right, so here we go, 3-variable map. All right. What do we have? Okay, we have A, and this of course is B and C, 0, 0, 0, 1, 1, 1, 1, 0, 0 and 1. Let's plot the terms. A bar, B bar, C bar. So I've got a 1 sitting here, haven't I? I've got A bar, B bar, C. A bar, B bar, C. So I've got a 1 sitting right here. Then I've got A bar, B, C, A bar, B, C, where is A bar? A bar BC is here, sorry. A bar BC, I've got a 1 sitting here. Then what have I got? I've got A, B bar C. So that's A, B bar C. I've got a 1 sitting here. Then I've got A, B, C bar. A, B, C bar. I've got a 1 actually sitting over here. And then I've got A, B, C. I've got a 1 sitting right here. All right, let's see if we can minimize that. What's our grouping here? Well, look, this is a good group over here, and so I can say then that LCLR is equal to, what's that term there? Well, look, that's just going to be what? C, isn't it? Okay. Or, what's my next grouping? Well, I can grab these two together, can't I? Reading that off, what do I have? I have A bar, and what's coming across here? B bar, isn't it? So that's A bar, B bar. All right? And then the last grouping would be this grouping here, which would be A, and what am I seeing over here? B. So that is A, and that is B. All right? And so that is my last Boolean equation. Okay, here is a complete list of the Boolean equations that we've just actually derived. Now, why don't you see if you could have a go at actually maybe implementing these Boolean equations with gates? Look, give it a try. The Boolean equations really describe the logic here. You've got your inputs, you've got your outputs over here. So really, once you've actually figured out what the gates are, then of course you can actually build the complete state machine.